Today we talked about Spark and Spark Python API. Spark is a fast engine for large-scale data processing. Spark applications run as independent sets of processes on a cluster, coordinated by the Spark context object in your main program, or can be called the driver program. The Spark context can connect to several types of cluster managers, and the cluster managers split the work. Spark acquires executors on nodes in the cluster, which are actually processes that run computations and store data for your application. It sends the application code to the executors and send tasks to the executors to run multiple executors per machine. Now we talked about Spark components. Spark components combine SQL, streaming, and complex analytics. Spark powers a stack of libraries including SQL and data frames, MLlip for machine learning, GrabX, and Spark streaming. You can combine the libraries seamlessly in the same application. Spark Core contains the basic functionality of Spark. Components for task scheduling, memory management, fault recovery, iterating with storage systems, etc. Spark Core is also home to the API that defines the Resilient Distributed Datasets, or RDD. And RDDs represent a collection of items distributed across many compute nodes that can be manipulated in parallel. Next, we talked about Spark SQL. Spark SQL works with structured data, and it allows querying data via SQL as well as via Apache's Hive variant of SQL, or we can call Hive query language. And it supports many sources of data, including Hive tables, Bucket, and JSON. Now we talked about Spark streaming. Spark streaming is a Spark component that enables processing of live streams of data. There can be log files generated by production web servers, or queues of messages containing status updates posted by users on a web service. Spark streaming provides an API for manipulating data streams that closely matches the Spark Core's RDD API. MLlip is a library of machine learning algorithms including classification, regression, clustering, and collaborative filtering, as well as supporting functionality such as model evaluation and data import. It provides some low-level ML primitives, including a generic gradient descent optimization algorithms, and all of the methods are designed to scale out across a cluster. GrabX is a library for manipulating graphs, For example, social networks, friend graphs, and performing parallel computations. Spark can run on a variety of cluster managers such as Hadoop Yarn, Apache's Meso, and a simple cluster manager called standalone scheduler. We can use either Python or Scala for programming tasks with Spark. Scala is more popular and Spark is built by Scala, so Scala is native to Spark. Now we talked about Spark context. The first step of any Spark driver application is to create a Spark context. The Spark context allows your driver application to access the cluster through a resource manager, for example Yarn or Spark cluster manager. To create a Spark context, we first create a Spark conf. It stores the configuration parameters that your Spark driver application will pass to Spark context. Some of the parameters define properties of the Spark driver application, and some are used by Spark to allocate resources on the cluster.